Oi. Acho que tá mais. Oi. Esse é melhor. Beleza, vamos começar? Good afternoon. My name is Fernando. This is actually Carly. We're going to talk a little bit about how you're trying to serve the open source community with continuous integration, continuous delivery. I want to first thank Fisl for their amazing event that's happening. It's been amazing days and all this stuff. I hope I'll be here next year talking or like going to talks and everything. It's been an amazing experience. I want to start the presentation with a simple question. Is that how long would it take to your organization to deploy a change in one single line of code to your production environment? It seems to be a simple question, but it can bring a lot of problems. You start to think of how your organization handles your process, deployment process, and your testing process. Things like, do you have to wait for 6 hours managing the deployment? Do you are confident that your software in that time it is good to go to production? Do you have to call like the database team, or you have to call the deployment team? You have to call the OS team? How do you handle this? How fast it is if I had to change it now? One of the problems is that your code base cannot be in a stable position. To try to solve this, what you actually had to do in order to think it is cool is that you build your software in such a way that it is always ready to go to production. We have to guarantee that no matter in what time, if an emergency comes, you're going to deliver, you're going to fix a bug that is in production right on time, and you're not going to have problems with that. One of the things that we believe is the first step to do to have a reliable product like this is actually doing continuous delivery. I'll go a little bit about the flow, what continuous delivery is. So imagine that you have a team that is actually coding. You have a local changes here, and then you push it to a version control, like Git or SVN, or whatever. We send that change to a process, which you guarantee that your software is working. This process can involve like automated tests, functional tests. You can see like performance testing. You can have steps as manual, exploratory tests, the way that you can guarantee that your software is working after that thing. So after you go through the process, everything goes right, you guarantee that your software is in current version, it's working, it's cool, it's ready to go to production. As long as, in the moment that you actually deploy that to production, you're doing continuous delivery. So you guarantee that your software is actually always working and that you can deploy that in an easy way, in a reliable way. So when you're doing continuous delivery, you have some things that you can achieve that will help you do this. First, it's continuous integration. So you guarantee that no matter how many people are working in your code, no matter where the teams are, no matter what is happening in the code, you guarantee that the current branch, the master branch, the trunk, or wherever, it is working, is a perfect state to go to production. If it is not, you have to fix it as fast as possible. You need automated tasks. So I was talking about deployment problems. You have to find a way to have automated scripts to deploy your application to production environments, to build that environment. Your local machine has to be as close as possible to the production, so you don't face any surprises like a patching the database is different, or environment variable is not set, and all the stuff. And as soon as you got your hand on those two first, you're going to actually have a repeatable and reliable process that you can keep delivering and deploying that to production, and you just relax because you know you rehearsed that before you try different environments, and you know that things working. That's the first step for continuous delivery. But actually, you should not stop there. There's more than that. So imagine that you have a website. You have everything automated. You have a good continuous integration process. You have users using that. Hopefully, you're going to not be in that position, but you're going to have like 1,000 of hundreds of users using that. and every time you're deploying your application, this is gonna bring some troubles. You're gonna start facing some troubles. So when you're actually deploying software, there are some things that you have to be careful of. First things like database migrations. If you're running database, or if you're creating the tables, you're changing some tables that are already there. This might take some time, even more if your database is huge. You gotta do infrastructure updates. Like you may need to update your load balancer, update the servers, or update the kernel of that and packages and all the stuff. You may have to restart some services, your HTTP server or anything else. So this thing might it might take a lot of time or some time, and you can't afford to stop your application. Users should not stop using our application of that. So imagine just like if Netflix had to wait for everybody to stop like watching a movie to actually upgrade it. If they stop the service, it will not. You don't want that. You don't want their users facing that. So what we actually want in that time is what we're calling zero downtime deployments. It's a deployment process of your application. It has got to be transparent for the user. So you should be able to deploy as many times as you want in a day, in an hour, in every 10 minutes, I don't know. And this should not affect the users that are actually using your application in that time. So I'll talk a little bit about who we are. As I said before, my name is Fernando. This is Akshay. We are both developers working on the Snap CI from ThoughtWorks. Snap is a tool that helps you do continuous integrations for repositories on GitHub. It's a system as a service. He helps you the first steps of continuous delivery. And as we use a lot of open source projects in Snap, we wanted to give it back to the community. So Snap is actually free for any open source project that you may have or you may work on. We're going to tell you a little bit of the story and how we achieved the zero downtime in Snap. And it starts from here. We got to know Snap a little bit from the insides out. So let's go a little bit from the cycle of how's the flow of the application in Snap. So imagine that your team are coding and you did a git push, you push some changes and want to verify that, go through all those process, verifying the software is still working. So what GitHub will do first is letting us know that there was some changes made in that repo. He'll send like a webhook. He'll tell us, hey Snap, somebody did some changes in that repo. Do what you want to do. Yeah. So we actually get that change together with what we call the pipeline. So GitHub will give us the head of the repo after that push, the actual repo, and the commits on that push. And what we're going to do is that we're going to get your pipeline and run it against that change. Your pipeline may contain all the process that you want to guarantee that the software is working, like running unit testing, running functional testing, running security checks, performance changes, and then as you can see, you have a lot of different stages on that. The idea behind having stages is that you want this feedback to come as fast as possible. So you wanted first to run things that are fast, and then it can give you like critical errors, like your project's not compiling, or it's a really big error it's breaking everything that was behind. So it's gonna be like usually unit testing that is gonna be fast, and then you can jump to tests. Think that you test the system as one black box, like functional test, but that is gonna take long. So that's why we have stages in Snap. We think that it's better for you to have the fast feedback first, and then you can wait for the other ones. After we get this, we actually build what we call a build request. There's the connection between your pipeline and a given commit and a given push. We save that on the database together with the build pipelines or build requests for everybody, right? So you have a lot of different users, a lot of different build requests in the database. We have something that we call the babysitters. They are actually workers. They're going to babysit your build request through Snap. So they're going to get there, they're going to prepare the machine, they're going to set everything up. And how they work is that we have the queue. Each one gets one job and starts running that. In the running process, what we actually do is that we prepare a container, which is a virtual machine that will run your build and your tasks there. We start databases that you want, like MySQL, CouchDB, MongoDB, whatever you're using. It sets the path for different languages. If you're using like Python 2.6 or 2.7, Ruby 2.1, we are going to set that for you. We're going to configure your machine. We are going to download artifacts that you may have, like if you're running one stage that needs, like usually when you compiled languages like you can do with Java, you can build a war or a jar and test against that thing. We are going to download that and put in the place that you tell us. We are going to do the git clone against that shard that you had. We run each pipeline stage one after another in the automatic stage. We're going to we're going to keep doing that until all the pipelines ends or stage fails. Like if stage fails, you're not going to do anything. It'll let you know that the stage is failing. Or if you reach a main stage or deployment stage as well. And after, if everything goes right, we can upload the artifacts that can be like the war result of that thing, the jar, or logs for your tests and screenshots for Capybara, whatever you want. So after running this, we can get in the way to tell you if the changes are good, it is actually green, if there is red, if there is some problem during the pipeline, and the artifacts that you may have in there. Looking for an architecture overview, it's quite simple. It's a web application, pretty basic. We have the load balancer. That is actually our gateway between the internet and Snap. That's where you, as a user, will connect to Snap through this guy. We have a web server that actually runs on Apache and responsible for getting the GitHub hooks and sending them to the database and all this stuff. We had as well a build server who runs the background jobs, the babysitters, the build queue is there, and the artifacts, he handles the artifacts, downloading, uploading, putting that on places that you want. We run OpenVZ containers, is also open sourcing. It provides us the virtual machines that we want, the containers where your build is going to run. So that's basically our architecture. We had a pretty good deployment process before doing any changes. We have automated scripts for almost everything. Like I joined the team in 40 minutes maybe. I had all my machines set up. I run like 3 or 4 lines of a script and everything was set. I would start coding right away. We had a deployment pipeline which will guarantee us that the changes that were sent were good. We run tests. We had like smoke environments. We have stage environments. We are doing everything that we thought was correct. And we had one-click deploy, in the sense that we should just like click one thing. It will run a script that will deploy for the production pipeline. That thing quite didn't work for some reasons. First thing is that we have to wait for the builds to finish. So imagine that you're a client or you're a user on Snap, and then your pipeline is running, and then suddenly it stops, and then you lose all your data and all those things. We didn't want that to happen. So in order to update our application, we actually had to wait for every build that was already running to stop. This could take like 10 minutes, 5 minutes, 2 hours, 3 hours. We didn't know. So also we had to put the app on maintenance mode, which